Empty seat still. So let me just point out to you, our first quiz is going to be this Thursday. Today's a little weird because I had to go over the syllabus, and I'm doing a lot of lecturing today. Normally I'm going to do lecture, and then there's going to be group work, where I give you a little worksheet to work on, and then some more lecture, maybe another group work. You with me? Today's just a lot of stuff in Chapter 1 just to throw at you. Tomorrow I'm going to have a group work thing on the definitions that we just went over, so that kind of gets you ready for the quiz the next day. Right? So just be ready for that. So I'm going to cover all of Chapter 1 this Thursday. Let's do that.
Is that all Chapter 1 by Thursday, or?
All of Chapter 1 will be on this quiz. Yeah. Oh, got so many erasers here. It's crazy. If you're just now rejoining us, pay attention to the fact there's a quiz this Thursday. Tomorrow I'll have some group work covering the stuff from Chapter 1. All right, so I'm going to take a step back here real quick. I almost always forget to do this at this point, but there's two kind of other ways to look at data. Believe it or not, it's like, holy shit, how many ways can you look at this stuff? There's one type called continuous data, and there's another type called discrete. Now this, to be very honest with you, is more important than the other ones, to be honest. Doesn't mean that the other ones aren't going to be on a test or a quiz or whatever, but this is what's going to show up a lot more often throughout the semester. There's going to be whole chapters devoted to ways of working with continuous data, and this whole chapter is devoted to ways of working with discrete data. You guys with me? Because there are certain things you can do with this that you can't do with that, and vice versa. Continuous might be the one to start with. If it's continuous, what does that mean? Yeah, and if I had a continuous line, it doesn't skip, right? This line is not continuous. You with me? It jumps over certain places. So continuous data is data that doesn't jump over any possible values. So all measurements, almost all measurements, let me be careful. Almost all measurements would be continuous. So like your height. Now, how would you describe your height to somebody? You would say like 5'5", 6'2", right? You're not going to say 6.1974 feet. Oh, who the hell are you? But could you be more specific with your height? Yes. Could you be more specific with the weight of your backpack? How about how far away you live? You're not going to say to somebody, yeah, I live 17.3555516.296 miles away. Yeah. Thank you for that. All right? You're not going to say that, but could you? I'm trying to make a big point here. I don't try to trick you, but on a quiz, I will say, identify the data as discrete or continuous, and I'll say my backpack weighs 8 pounds. And people say, it's discrete because it's a whole number, there's no decimals. No. To be discrete or continuous, can the data be made more specific? So continuous doesn't skip any possible values. The weight of your backpack would be from 0 to whatever the breaking point of your backpack is. You with me? It's not going to skip any. If I put a grain of something in there, or I put a quark in there, you guys know what a quark is when you break things down all the way down. Drop it in there one by one quark and another quark and another quark. Then my weight's going to increase like really small amounts. Do you kind of see what I'm saying? But if I said how many doors are on your car, and you say 4, and I say, can you be more specific? You're going to look at me like, what? 4.0, right? You guys with me? Even if you have, does anybody have a truck that I think sometimes they call them half doors. They got like half a door is basically, So that's still discrete because could that have 2.659 doors? No. So does the values of that data, does it jump over possible? Yes, it does. You can't have 0 doors, but you can have 1 door, 1.5 doors, 2 doors, 2.5 doors, right? Are you jumping over a lot of, oh yeah, you're jumping over an infinite number of things, aren't you? How many numbers are between 1 and 1.5? Infinite number of numbers, holy shit. So continuous doesn't skip over any possible, so weight, height, any measurement really, almost any measurement is going to do that. You can be more and more specific and it would make sense. But how many people are in your house? 2.7. I am not coming to your house, right? That Cronenberg little 0.7, whatever the hell. Morty, I put some. Sorry. Rick and Morty? Anybody? No? Okay. Oh, jeez, Rick. So continuous does not skip over any possible values, right? So the word continuous makes total sense. Whereas discrete does. Discrete, normally you think of it as being able to count the values. How many cars on the door? I like that. Come on down to my shop. Cars on the door. No. How many doors in the car? Well, you can count 1 door, 1.5, 2. But if I said, now count the possible weights of a backpack. No. There's an infinite number of them. You see, so discrete you often call it countable. Well, there's something called countably infinite, but that's not so crazy. So discrete does skip possible values. Finite. Countable. Whereas this has an infinite number of possible values. So what about price as listed of gas? Price of gas is listed in a gas station. So could they list for the price of the gas at a gas station 3.37486964662222222? Well, I love this. I love this. Why not? Some weird. Have you ever seen that? Now, it's not a question of is it possible for somebody to do that. Would somebody do that? No. You with me? If you see it, take a picture and send it to me, please. Do you understand what I'm saying? It's not, are there decimals in the numbers? It's not this at all. Right? You wouldn't say, so how much could gas be? 3.179? You ever notice that 9 at the end? Have you ever noticed that third decimal? Anyway,
9 over 10.
Say again?
Don't they have like 9 over 10 for the cents?
Not exactly. 9/10. Yes.
So that it has like a fixed or natural ending point. Like Bitcoin has 1 million, and that's the normal unit to use because it's so expensive. And so would that be considered discrete because that's like the ending number?
Yeah, because it's the not is there an end to it? Because like I said,
like
the weight of a backpack, the end would be basically where the backpack is no longer a backpack. It just kind of tears apart. So there is an ending. So between the beginning and the end, it doesn't skip any possible values. So it's not is there no ending? It's just that between the beginning and the end, does it skip anything? So again, if I said, how many kids do you have? You can have from 0 to whatever. You skip possible values. You don't have 3.4 kids. I don't care how much the kid sleeps or whatever, right? A little scared about that 0.4 kid. Leave them up in the bathroom, upstairs somewhere. So you guys kind of get the idea here? I mean, can you count the possible things it could be? Could it be like forever decimal and make sense? So is that how tall are you? You're not going to tell me 5.9834, but could you? Could you measure it? Yes. Okay, I like it. And the thing about the gas station price, as listed, right? Not, how could you measure, but as they list it. I'm very careful with it. Okay. So, I'm going to try to do a couple more things. I know, trust me. So again, this is 16 weeks condensed to 4. Will every day be like this? No. Today's kind of a lecture-heavy day. I don't like talking this much normally because that's when people kind of like, So normally I'm going to break it up with some group work. You guys can actually get to meet each other. Wouldn't that be nice? You know, there's weird people sitting around you. Who are these people? So tomorrow I'm going to let you kind of meet some people. Today's a little weird, right? I'm going to try to do a couple more things, and then we might try to head out a little early. Well, we'll see where we end up. Okay. I kind of had a little foreshadowing for this earlier. Different ways of sampling from a population, right? So sampling techniques. All right. So, the most basic form of sampling would be if you were my population and I just put everybody's name or ID number in a hat and picked it out. Now, what type of sampling would that be? Random. Truly random. Everybody had a chance to be in the sample, right? Everybody had an equal chance because they didn't put 2 slips of paper in there for you, right? So the most basic type is random. Now, some of the other types have to be random also, but random just means there's no extra process involved, right? You'll see what I mean when we talk about some of the other ones. Random is just like everybody has a chance to be in the populations, in the sample. So like numbers in a hat. So now, when I start talking about the other types, you'll see what I mean. So the second, let me see. Which one do I want to do now? Let's do, let's do clustered and stratified now. Let me make a little room here. Cluster, stratified. Okay. Stratified is actually the one that I heard a few people say earlier. Just stay with me. I know the words are new. The words are new. Cluster is not new. Right? There's another that you can add to the end that you might have heard before. But cluster, it's gonna. These two are very similar. That's why I want to talk about them at the same time. I'm glad some of you guys got them. They both start with the same first step. Break your population into groups. So it could be like it's already broken down, like freshmen, sophomore, junior, seniors at a high school. You with me? Or you could force it to be broken down across demographics or whatever. Or you could force it to be broken down just by people on this side and people on that side. I mean, just the first step is to break your population into groups. So let's say the people in each row is a group. You're a group, you're a group, you're a group, you're a group, right? Who's my favorite group? I don't know. So that's the first step for both of those methods. Cluster would say randomly choose a certain number of groups and take everybody from that group to be in your sample. So cluster would go, choose you, and I choose you, and I choose you. So everybody in those rows would be in my sample. Why is that still random? Remember, what does random need? Everybody in the population, and my population is everyone in this room. Everyone in the population has to have a chance to be in the sample. Now, what's funny to me is when I say I choose you randomly and you, somebody goes, well, she's not in the sample. That's not random. No, do you see, that's not the right way to look at it. Could she have been in the sample? Of course. I just happened to not pick that row. So did everybody have a chance to be in the sample? Yes. Of course they did. I like it. Okay, I like it. So cluster would be some, again, there's some, all from some. That is the phrase to remember. You take all from some. So you take some rows and you take everybody from those rows you picked. Or you pick, like I was thinking about this, there's 3 classrooms right now with people in it, and I take 2 of them randomly and take everybody from those classrooms. So screw this classroom. It's still random because everybody had a chance to get in there. I could have picked this class. I could have. You guys with me? So don't look at the end result and say, we left those poor people out. Well, I'm going to have to leave somebody out. It's just a sample. Could they have been in there? Yes. So you see what I mean? This is still random, but it's with a process on top of it. So if you answer, if the answer is cluster and you say random, you're wrong. You're going to answer with the more specific answer. It's cluster. What about stratified? What the hell would that do? Well, that was the earlier example. If I have 3 classrooms, I would take maybe a couple people from each. Some from all. It's crazy. I'm trying to make a Three Musketeers things out of that. Some from all. So these two would be in my sample. You could do what's called proportional sampling. So if there were 80 people in this classroom and 20 people in this classroom, I would take 8 people from here and 2 people from there. You see proportional sampling? This sounds a little bit like American government class. Think about the two different houses, the House of Representatives and the Senate. Anyway, some of you guys are like, I don't know. Shit, all right. How do we know so far? Is it those two there? They're very similar, but it's that second step. Look. Stratified. Some from all. All right. Oh well, shit. It doesn't always work. Cluster completely everybody. No. All right. So then, what about another one? There's one called systematic. Every time I say that, automatic, systematic. That song is a little bit older, so I'll let you go on that one. So what do you think about this? What's the root word here? System. So I did give an example of this earlier. This is where instead of taking everybody from some rows or taking a few people, so the stratified for the rows would be, I take like 1 person from you guys and 2 from here, so I'm going to do proportional sampling. There's less people in that row, so I take less from that row. But I take some from all. That would be stratified. Are you guys with me? Systematic would be, I pick a person randomly to start, and then I take every 5th one after that. There's a system to it. Or I take the temperature outside every 20 minutes. Every blank. Every n thing, every n minutes, every n whatever. There's a system to it. That one's nice and easy. I don't know what else to say there. So like every nth item or every nth minute or whatever. Yes? Yes, incremental. I like it. The reason it's still random, somebody could argue, well, the people you skip had no chance. But remember, where do I start? I pick somebody randomly to start at. So could you have been picked? Yeah, I could have picked it. I could have started somewhere that they would end up on you. So that random beginning is what makes it random. When would you not want to use systematic? There's a certain situation where you don't want to use systematic. Let's say I'm checking out what is it called? Conveyor belt assembly line. And there's a machine, I have in mind, probably from watching too many cartoons, I have in mind this machine, it goes, ka-chunk, ka-chunk. And like the 4th piece of it, it goes, ka-chunk. It's defective. So if I take every 4th thing, I'm going to think, holy shit, everything's defective. When actually it's just like 25% of it's defective. Or if I take every 4th thing, but I don't start on that one, oh, everything's great. And I have no idea that there's a problem. So if there's something in your sample, in your population that might be cyclic, that might be, happening in a cycle. Do you guys understand what I'm saying? Is this really important? Not really, but I still want to tell you. There are certain times you don't want to use certain ones of these. Now, real quick. One semester, somebody who was, I think they were in the Army, and they had been in Iraq, and they said cluster sampling is bullshit. And I said, can you expand on that? And the next day he came back, or what was it? He told me something that I researched it, and what it was when they went back in to check to see how things work. This is very soon after Baghdad fell, I think. They did cluster. They broke Iraq up into territories, but they only went to the territories that they knew weren't going to be too violent. Do you understand? And if your purpose is to see how safe things are, and you've biased your data by that, it's crap. So it wasn't cluster sampling itself that sucked and we should throw it out, is they didn't use it correctly. Right? If there are certain clusters that you don't pick from the beginning for a certain reason, that's not random. They don't have a chance. You're like, I don't like those people. So we're just going to take, no, it's not random then. They didn't have a chance. There's no chance for them to be in there. Maybe. Okay, and the last one, I choose this for the last one because it's the worst one. It's called convenience. So if I would have used all the females in here as a sample to figure out an estimate for the average height of females at Grossmont, that would be very convenient for me. I didn't have to do any work. I didn't have to try to make sure it was random. You guys are here. If you don't tell me your height, I'm going to fail you. So do it. It's very convenient. I didn't have to do any work to make sure that it was random. So that one's kind of like, it's a giveaway, right? I stand out front of a music store and ask people's opinion about music. I'm like, well, that's not good. You didn't do any work to try to make sure that it was random or anything. Or maybe. Okay. Yes.
So not everyone has equal chance.
No, not necessarily. It's just that you did no work to try to make sure that it was random. So if you use convenience sampling, could your sample actually be good? Yeah. It's just that I can't trust it to be good. And if I randomly sample, if I randomly sampled every third person, I just randomly picked you, and then every third person, and I got their shoe size or whatever, is it possible that I happen to get all the really large-feeted people? Feeted? I like that one. Large-footed people. Is it possible? Yeah. Yes. But I did my best to make sure it was random selection. So that means that my results could still be published. That's why they have to be repeatable. Do you understand? That's why the first time you see something mentioned from science, you wait for the next one to say, we verified that. Somebody else on the other side of the world went, we got the same thing. Then you're like, holy shit. All right. Okay, maybe. Okay, what time is it? Oh, we're doing pretty good. So one last thing. What were you? Last thing. I forgot already. Oh, let's see. Oh, good. I did that. I think I might have done. I did you. I love it. Oh. Nah. We're talking about that too early. Okay, let's talk about this. This will be the last thing. Is everybody cool with this? All right. Real quick, I did have a teacher once that, if I ever did this, I would have to retire immediately. We asked him, what did you write? What's that you wrote after number 3? And he went, does somebody remember what I wrote here? So the day that I can't read my own writing is the day I need to retire. I can still read it, so you guys are like, good for you, man. I can't do it. Okay, so last thing for today, and we'll head out a little bit early. Don't get used to that. This one sort of bleeds into the next chapter too. But let me give you a couple things here. There's something called a bar graph. And you guys have all seen bar graphs before. But normally, bar graph means that you have qualitative data. So some of you guys might have the wrong image in mind. A bar graph, bless you, would be like men, women, and I don't know. The number said yes to some question, right? I'll let you guys make up your own example where the question might have been. You guys with me? I mean, so this is men, women, and the number of men, the number of women, right? So this is qualitative down here. You with me? Or you go out into the parking lot and you start to count how many Hyundais plus how many BMWs, blah, blah, blah. So there's no scale to talk about. They're not numerical. So there can be a gap. Why is this gap okay? Do I think that there's... Now this could be a different discussion, right? And anyway. So I'm not leaving anybody out here. You have to identify, well, you don't have to. Well, this is a really interesting area to get into. I'm going to stay away from here. You can't be, your Hyundai can't say, I decide I'm a BMW. You wish it could, but it can't, right? So since there's a gap here, does that mean like I'm skipping something or I missed? No. This is Hyundai, this is BMW. Whereas for quantitative data, I'm going to use what's called a histogram. Dang it. Because that's got an actual scale to it. I don't want there to be any gaps because that would mean that that there's nobody there or I missed something. So like if I said age of people at a bus stop or something, right? Maybe there's a few there. There's more there. There's more there. You kind of with me? If there was a gap between two of them, that would make me go, oh, wait a minute, there's none of those people? There was nobody there that was that age? There can't be gaps unless, like, there was nobody. Like, there was nobody from 50 to 60. Now that gap tells me, oh, there was nobody there. So the gap, if there's not a bar there, it's got to mean something. It's got to mean that there was nobody there. Here, does this mean anything? No, it's just the separation between this group and that group. This is in groups. This is truly numerical. There's a scale to it. That's the main difference between bar graphs with the gap in it and histograms. Yes, sir. Yeah, names, numbers. I love it. For the most part. Now, how would I go about constructing something like this? Well, I could create what's called a frequency table. Okay, so that's the last thing we're going to talk about today. Some of you guys are like, okay. So we got this here? Yeah. So if I said, 28 men said yes. This is that first image I had up here a second ago, right? And 9 women said yes. Then I can make a bar graph. What kind of scale would I use on that vertical axis? Oh, shit.
Dot?
What kind of scale? Yeah, I want to get up to 28. So maybe 5s. Give it a little better resolution. 10s maybe could work with that, but 5, 10, 15, 20, 25, 30. Right? So then men, I would make it up to 28.
Sure.
And women, I would go up to 9. Cool? Not too bad. So frequency is just how frequently something happened in this group. In this case, it's the number of times people in this group said yes to some question I asked them. You guys with me? It's not too terrible there. Now, as there's something that we have created as humans. We created this, which is why math doesn't work with it directly. Percentages. And I've noticed, unfortunately, fewer and fewer people coming out of high school understand percentages. I mean, it used to be a lot better. Now it's holy shit. And maybe it's not your fault. Maybe it's just the way that I don't know what the hell it is. It's to be honest. But fewer people understand percentages. So for example, a store has a 20% off sale, and they say, we'll take 30% off on top of that, so it's 50% discount. No, it ain't. That's bullshit. If they have a 20% off sale and they take 30% off on top of that, why is that not 50% off? 30% off of a lower frickin' number. So it's not a total of 50% off the original. Right? So he told me it's 50% off. You take 50% off right now. Right? That's what he said. Screw you. Right? So it's like the store people better be like, okay, here's how percentages work, everybody. Right? But it's unfortunate. Everybody should know percentages because they're so useful and they are everywhere. So few people seem to understand it. So, for example, if I got a 10% pay cut all of a sudden, by accident, right? Let's just say, and then I go complain, and they say, "Oh, I'm sorry, we'll give you a 10% raise." I'm a math guy, so I'm still pissed. Because again, it's sort of the same idea. Once I'm 10% down, if they give me 10% of that back, do I get back to where I was? No, because it's 10% of a lower frickin' number. I don't get back up to where I was. You guys start to understand. So percentages are sort of like probability. We created the idea of percentage. We have to then teach ourselves how they work. It's not inherent in our brains. But percentages at the same time make more sense to us. So here, I'd rather know the percentage of men who said yes. That'd be a much more useful number to have. So how would I figure out the percentage here?
Out of how many?
Yeah, how many total people did I talk to? 37? Yeah, well, so 28 divided by 37. And this is what's called the relative frequency. See why I call it the relative frequency? Relative to how many people there are, that's what this frequency tells me. So what is 28 divided by 37? Somebody help me out. 18.
0.756.
I was almost there. Yeah, it should be like 0.77. 7567. And then 9 out of 37, of course, would be 0.2433. 32. No, well, this should be, well, screw it. 32 what?
4.
So this was probably 6, 7. So it should be it. I'm with you. Never truncate, always round. Sorry, buddy. You're like, I'm not going to speak up again. No, shit. It's a really good time to make that point. But later in the semester, I want you to give all probabilities and stuff to 4 decimal places. And you always round. Don't just chop it. Because then you're lying, basically. You want to be honest. So then I can make another scale. I can make a different scale. I can make these percentages, really. 75.7%, just to round off a little bit. 24.3%. Right? And it's going to be the same picture, it's just going to be a different scale here. Instead of pure numbers, it's going to be percentages. I can go, well, now I'm going to want to go up by like 10 maybe. Maybe even 20. You guys get the idea here? So that I could do a frequency paragraph, relative frequency paragraph. I can do a frequency histogram, relative frequency histogram. That's what we're going to focus on in chapter 2, is the histograms. All right. You guys all right? All right. So like I said earlier, it's a really good idea to work on the homework immediately. Right? And Mark came by. He's going to be in there right now. If you want to go over there and do your homework there. I'm going to hang out here for a little bit if you need to talk to me. If you need to add code, you haven't got it yet. Coming up here, I can give you one of those. If you have any questions or concerns, I'm going to be in here for a while. Yes? Yes. I'm not sure what day. I think they'll give you a grace period. Probably just one day. Yeah, you need to go by the cashier's office, I think. Yeah, they should have an expiration date on them if you have one already. It should tell you when they stop. Those expired?
Yeah, for the fall. Oh.
The fall one's gone. January. I put my start one on.
That's it. It doesn't go all the way.
Oh, it doesn't go all the way through intersection. Oh. I got you.
Would always be